Hello everyone, I am Dr. Chander Pawar, working as Associate Professor in the Marri Laxman Reddy Institute of Technology and Management. I am the Faculty of Chemistry, and today we will be discussing something about a remaining part of our second module, that is nothing but battery chemistry and corrosion. So we are about to end our module, and today's topic is factors affecting the corrosion. Okay, so basically, what are the factors affecting the corrosion? Apart from the atmospheric oxygen and moisture, there are some factors like gases, hydrogen sulfide, ammonia. These gases are also sulfur dioxide. These gases are also responsible for the corrosion. And apart from the corrosion, basically in salt environment, how corrosion will be faster than the normal environment, and how temperature related to corrosion, and many other factors which are mostly influencing the corrosion. Okay, so basically here we can see majorly two types of factors are affecting the corrosion. So first one is nature of the metal, and second one is environmental factors. Okay, so when we talk about nature of the metal, how nature of the metal leading to the corrosion. Okay, there are several factors in subcategorized into this: position of the metal in the galvanic series, purity of the metal, physical state of the metal, solubility and volatility of the corrosion products, relative area of anodic part and cathodic part, and lastly nature of the oxide film. So these are the 6 factors which are influencing the corrosion, and that comes under the nature of the metal. Okay, now second factor is environmental factor. So environmental factor, first one is corroding environment nature, temperature, how corrosion is related to temperature. Okay, and then humidity. Okay, humidity, moisturous atmosphere, and then pH value. So how corrosion is related to pH: acidic pH, neutral pH, basic pH. So in this acidic, basic, neutral pH conditions, which one is more detrimental for the metallic corrosion? That will be comes under pH value. And impurities in the atmosphere. Okay, and finally oxygen concentration. If more the oxygen concentration, the corrosion rate is also more. Okay, so we will see these details in now. First one, which is nature of metal, and in that subcategory, first one is position of the metal in electrochemical series. Now we can see here lithium is there, potassium is there, calcium is there, sodium, magnesium, aluminum, zinc, nickel, tin, hydrogen, copper, silver, platinum, gold. These are some of the metals in electrochemical series. Now when we talk about first element, that is nothing but lithium, the corrosion rate for the lithium is more, whereas for the gold, which is bottom, it is less. Why? Lithium atomic number is 3 and 3 electrons are there, 1s2, 1s2, 2s1. Now what will happen here? Since there is a valence electron, so the oxidation is more in the lithium metal. And when we go down from the lithium to potassium, calcium, sodium, magnesium, aluminum, zinc, nickel, tin, and copper, silver, platinum, gold, so the corrosion rate is decreasing. Why? Because oxidation rate is less. Corrosion rate is top to bottom. corrosion rate is decreasing because oxidation rate is low. Okay. Now let us see. Here silver is there, platinum is there, gold is there. These three are, we call them noble metals. Okay. Silver, platinum, gold, we call them noble metals, like noble gases, helium, neon, argon, krypton, xenon. So this silver, platinum, gold, these are the noble metals, NOBLE, noble metals. Why? Because their outermost electronic configuration is, electron cell is completely filled. So there is no oxidation at all. No oxidation. No oxidation means what? No corrosion. Okay. That is why gold, silver, platinum is all the time shiny. They are not getting any oxidation. Since they are inert with the atmospheric conditions, they are called noble metals. They don't react with any atmospheric components like water or oxygen or temperature or oxygen, whatever it may be. Okay. So that's why these silver, platinum, gold are very precious elements. Why? Because they are shiny all the time. They are not getting corrosion. Okay. Now top to bottom, from lithium to potassium, calcium, sodium, magnesium up to silver, platinum, gold, there is no oxidation. Oxidation rate is less. Oxidation rate less means there is no corrosion at all. Okay. That's about the position of the metals in electrochemical series. Okay. Now purity of the metal. A pure metal is more corrosion resistant than impure metal. If there is a metal or copper wire or any steel or stainless steel, okay, more the pure, it is resistant to corrosion. And if it is impure, means combination of any other metals, it is much more having the affinity towards the corrosion. Okay. Now pure one, less corrosion affinity. Impure metal, more corrosion affinity. Okay. Now the rate and extent of corrosion increases with the amount of impurities present in the metal. Very straightforward. Okay. So as the impurities increases, the corrosion probability is more in the metal composition or metallic material. Here we can see there is a pure copper wire, no corrosion at all. But here it is impure one, there is a nails. Carbon, nail is nothing but iron, carbon plus iron. This is something like steel. Okay. What is happening? Rusted one, corroded one. What is the formula of rust? Fe2O3 NH2O. This is the formula of rust. Rust is nothing but corrosion. So pure copper wire doesn't get the corrosion, whereas impure one gets more corrosion or faster corrosion. Okay. Now another state, physical state of the metal. As we know that smaller the size of the metal, more the area under stress and greater the corrosion. Yeah. As per the statement, surface to volume ratio. Smaller the materials, finer the particles, more the surface area to expose. Okay. So microparticles, nanoparticles. So which one is having more surface area? Micro or nano? Nanoparticles are having more surface area. Why? Because smaller the size, more the surface area. Okay. So, volume to ratio, surface volume to ratio. Now, smaller the size of the metal, that means area under the stress or exposure is greater and corrosion is more. Here we can see there is a single particle or single metal. When we chop it or break it down, okay, surface area has been increased, particle number has been increased. So, surface area increased means exposure to atmosphere is more. So, exposure to atmosphere more means corrosion rate is more. Corrosion rate is more. Okay. So, more the exposure of metal surface to atmosphere, greater the corrosion rate. Okay. Now, solubility and volatile nature of the corrosion product. For example, there are 3 glasses A, B, C, each glass having water, and there is a nail dipped into this glass, water containing glass. In A case, nail is not covered with any part. In B case, nail has been wrapped with aluminum foil. You can see here, nail with aluminum foil, and we can see here there are some markings, or aluminum foil is covered on the surface of nail. And in third case, nail with copper wire, copper wire has been wrapped, you can see here on the surface of nail. So, now tell me, in which glass containing nail gets more corrosion? Obviously, answer is A. A is greater than, C is greater than B. Okay, why? Because in A case, nail is completely exposed. There is no any coverage on the surface of the nail. It is completely dipped into the salt water or any normal water or atmospheric condition. So, there is no protecting layer to this A case nail. Whereas in the B case nail, there is some aluminum foil wrapping, that means a protecting layer is there. Whereas in the C case, there is a copper wire wrapped on the surface of the nail. So, that is also a kind of protecting. But when we talk about B and C, aluminum foil and this copper wire wrapping, here aluminum foil has been covering the nail fully, whereas copper wire which is wrapped on the nail surface, that is not covering the nail properly. That means exposure area of this nail into that water is more. And whereas in the A case, there is no any protecting thing. It could be aluminum foil or wrapping of copper wire or anything. There is nothing else here. So, corrosion rate is in A case is more than the C and then the B. Why? Because protection layer on the nail, metallic nail. Okay. Now, we can see, okay, that is about nature of the metals, factors which are influencing the corrosion, which comes under the nature of the metal. Now, second category of factors affecting the corrosion is effect of environment or environmental factors. Nature of corroding environment, in this again there are several categories: temperature, humidity, pH value, impurities. Now, corrosion generally increases with rise in the temperature of environment. See, corrosion generally increases with the increase of temperature into the atmosphere. That means more the atmospheric temperature, more the corrosion rate. Clear? For example, there are two identical metal parts, part A and B. Identical means same. One is kept in room temperature, another kept at somewhere 40 or 50 degrees centigrade. Same metal piece, two A and B, same metal pieces. A kept in room temperature, that is somewhere 25 degrees centigrade, and B kept in temperature which is somewhere close to 50 to 60, assume. Now, which one gets more corrosion or faster corrosion? Obviously, which is kept in the 60 degrees centigrade rather than the room temperature or 25 degrees centigrade temperature. Now, to conclude, as the temperature increases, atmospheric temperature rises, the corrosion rate is more. Okay. Now, humidity. Humidity is nothing but humidity of the air. Rate of corrosion increases with presence of moisture in the atmosphere. For example, when we talk about Hyderabad, it's a dry weather, and when we talk about Vizag, Visakhapatnam, which is coastal, it's a humidified environment, humidified atmosphere. For example, again, there are identical metal parts A and B, same metal parts A and B. One is in the Hyderabad, another is in the Vizag. Which one gets corrosion faster? So, which is there in the Vizag, humidified conditions. Okay. Why? Because Hyderabadic temperature is dry temperature, whereas Vizag temperature is humidified temperature. So, obviously, humidified temperature containing exposed metal gets corrosion faster. Okay. Now, another one is pH value. Okay. In the acidic medium, corrosion is more, and in alkaline medium, it is less. Alkaline medium, something like basic nature. Acidic nature, somewhere pH 1 to 6. Okay. Which is 6 means pH 5 and 6 are slightly acidic, but less than 4, 3, 2, 1, that is too acidic. For example, now there is a metal part, one is kept at pH 2, another one is pH 5. So, which one gets corrosion faster? Okay. The metal which is exposed at pH 2 conditions, too much acidic rather than the pH 5. So, more the pH nature means more the acidic nature, greater the corrosion rate. Okay. Now, impurities, presence of impurity like carbon dioxide, sulfur dioxide, sulfur trioxide, hydrogen sulfide, sulfur trioxide. Okay. Acid fumes increases corrosion rate. For example, here I will tell you one best example. If there are some acid, nitric acid, sulfuric acid, HCl, this, that, so many acids are there. If you preserve these acids in a metallic cupboard, after few months, that whole metallic cupboard will be degraded and it will be catched corrosion. Why? Because of acidic bottles you are preserved there in the metallic cupboard. That is why to preserve acids like sulfuric acid, nitric acid, hydrochloric acid, the metallic cupboards are not recommended. To preserve such kind of acids, wooden cupboards are recommended. Okay. Now, here we can see temperature, as we talked earlier. Rise in temperature means greater the corrosion rate. Simple statement. Temperature, more the corrosion rate. Now, corrosion generally increases with rise in temperature we are talking. Let us analyze this plot. There is a red line which is a open system, which is related to open system. There is a closed system, and on the x-axis temperature in degree centigrade, y-axis corrosion rate. Now, as the temperature increases, closed system corrosion rate is more, and for the open system, even though temperature increases, for the open system corrosion rate is declining. Why this is happening? Because in the open system, whenever the temperature increases, whatever the gases are there, like sulfur dioxide, sulfur trioxide, oxygen, hydrogen sulfide, these gases will be reduced with the help of temperature in the open system. So these are all sulfur dioxide, sulfur trioxide, hydrogen sulfide, oxygen, these are all the corrosion affecting gases. And when you are increasing the temperature, the amount of these gases in the open system will come down. The moment these gases, amount of these gases come down, then the corrosion rate will also comes down. But in the closed system, though you are increasing the temperature, whatever the corrosion causing gases are there, sulfur dioxide, sulfur trioxide, hydrogen sulfide, oxygen in the closed system, those will remain in that system. Though there is an increase in the temperature, there is no chance to escape those gases like oxygen, hydrogen sulfide, sulfur dioxide, sulfur trioxide. Though you are increasing the temperature, these gases are not escaping. Why? Because it is a closed system. That is why in the closed system corrosion rate is increased. Okay. Now corrosion control methods. What are the corrosion control methods? Proper designing, using pure metal and alloys, modifying the environment, use of inhibitors. Now, proper designing, yes, any material, any purpose, whatever it may be the purpose or usage, it should be followed proper principles while designing. Okay. And using pure metals and alloys can also avoid the corrosion. Modifying the environment means it should not be too much hot temperature, or it should not be, environment should not be too much humidified. Okay. If you reduce too much humidity in the atmosphere, or if you reduce the too much temperature in the atmosphere, or if you reduce the oxygen, hydrogen sulfide, sulfur trioxide, sulfur dioxide kind of gases, then definitely we can reduce the corrosion rate. Okay. Use of inhibitors. Yes, we can use inhibitors like oils, grease. Basically metallic parts are always applied with some wax or grease. Why? This wax and grease will be acting as a thin layer on the surface of the metal, and with that what will happen, whatever the atmospheric moisture or gases are there, those won't be having direct contact with the metallic surface. So whatever the wax or grease layer is there on the metal, that is acting as a passive layer or protective layer. So we can prevent the corrosion or we can control the corrosion by using such kind of grease or wax or any other lubricants applying on the surface of metal. Okay. And cathodic protection, applying protection of coatings. Basically, if there is a metallic rod or pipe, so if it is coated with any paint or any wax or with any grease, we can minimize or we can prevent the corrosion. If any metallic rod or pipe is not coated with or not painted, then there are high chances to get the corrosion. Why? Because it is highly exposed to the atmosphere. Exposed to the atmosphere means what happens? Oxidation takes place. Oxidation takes place means what? It definitely leads to the corrosion. Okay. Now, cathodic protection again categorized into two types, that is sacrificial anodic protection, ICCP, that is nothing but impressed current cathodic protection. Let us see what is the beauty of this cathodic protection. Now, first part is of the cathodic protection is nothing but sacrificial anodic protection. What is that? The magnesium Mg is magnesium rod will be protect the steel pipeline from the corrosion. Why magnesium is protecting the steel pipeline? Because when we talk about magnesium and steel pipeline is nothing but iron and carbon. So iron and carbon is nothing but steel plus, okay. So here magnesium is more oxidizing metal. So if you apply this magnesium to this steel pipe, since this magnesium is having more oxidation, it will be acting as a coating or protecting layer to the steel. Unless this magnesium is corroded, the steel won't get the corrosion. Once whatever the protecting layer of magnesium is there on the steel pipe, and upon complete corrosion of this magnesium, then only corrosion leads to the steel pipe. Now here faster oxidizing magnesium is acting as a protecting layer to the steel pipe. Okay. Now what is the statement written here? Magnesium is more easily oxidized than the iron, therefore acting as a anode in the galvanic cell. Okay. Anode means oxidation. Anode means oxidation. Oxidation means more the corrosion. So here magnesium is more easily oxidized. That means more the corrosion rate than the iron. Magnesium greater than iron. Oxidation rate. Oxidation rate, magnesium is greater than the iron. Now, the steel pipeline becomes the cathode and oxygen is reduced, in turn protecting the steel pipeline. Here we can see magnesium, sacrificial anode. Anode means what will happen? Oxidation takes place. Oxidation means nothing but loss of electron. So whatever the electron released at the magnesium part, anodic part, this electron will be reaching to the cathodic part, and then finally it leads to the corrosion. So now, since oxidation is taking place at the magnesium, that is anodic part, so magnesium is acting as a sacrificial layer or protecting layer to this steel pipe or iron pipe. Okay. Now, last one is ICCP. ICCP is nothing but impressed current cathodic protection. What it is? In this method, an impressed current little more than corrosion current is applied in the opposite direction to nullify. Very simple to understand. How you are nullifying? At anode, what will happen? Oxidation takes place. Oxidation is nothing but loss of electron. Okay. At anode, whatever the oxidation is happened and whatever the electron is released, that will be reaching to the cathode part for the final corrosion generation. Now, whenever before reaching this electron to the cathode, if you send some external current, okay, external means outside current, which is greater than these electrons which are released at oxidation, then we can nullify these oxidation electrons. That means we are killing the oxidation electrons which are released at oxidation by sending the external current which is greater than these electrons. That means these electrons are not reaching to the cathodic part. Then there is a prevention of corrosion. Simple. So what you are doing? Whatever the anodic part, oxidation, electron release, so we are sending outside current which is greater than the electron which are released at anode, and we are bombarding, we are killing, or we are nullifying those oxidation released electrons. Why? Because oxidation released electrons, once they reach to the cathodic part, then only there will be a corrosion initiation. So before reaching these oxidation electrons to the cathodic part, we are sending the external current and nullifying those electrons. Simple, very nice concept. Then we can definitely prevent the corrosion. And hot dipping or tinning process. Hot dipping and tinning. Basically, let us see. It is a process of coating the base metal surface with zinc, tin, lead, aluminum metal. Example, coating zinc on iron by hot dipping method. It involves following steps. The iron metal surface is washed with organic solvents to remove oil or grease content on metal surface. Okay, any impurities will be removed by washing with some organic solvents. Then the metal is passed through dilute sulfuric acid to remove rust or any other depositions. So why we are using sulfuric acid? To remove the rust, to clean it, or any other depositions on the surface of the metal. Finally, the metal is washed with water and dried. The metal is then dipped in the molten zinc. Molten is nothing but liquidus zinc. Okay, molten metal is nothing but metal which is in the liquid form. What is happening here? First, we are taking tin or lead or aluminum, anything, zinc as well. We are making zinc, tin, lead, aluminum into the liquid metals, and into that this cleaned iron wire or any rod is dipped. While dipping, what is happening? If it is a molten zinc, zinc will be coated on the surface of whatever you are dipping material. It could be wire or it could be any rod. If tin is in the molten state, upon dipping into the molten state tin, the tin will be coated on the surface. If it is a lead, molten lead, means liquid lead, upon dipping again it will be coated. Similarly, aluminum. So, here hot dipping name itself, what we are doing? We are making molten metals like molten zinc, molten tin, molten lead, or molten aluminum. Molten is nothing but liquid metal. So, once we are making this zinc, tin, lead, aluminum molten or liquid, into that liquid we are dipping any rod or any wire, and then we will be taking out. Definitely there will be a coating on the surface of that metallic wire or metal rod. With that we can prevent the corrosion. Okay. Here we can see the metal is then dipped in molten zinc and passed through ammonium chloride or zinc chloride flux to prevent the oxidation. Simple. The excess zinc is removed by passing through the rollers by wiping. You can see here. Here it is mild steel or wire. What happened initially? It has been passed through the dilute sulfuric acid to remove the rust or deposits. Then it has been dipped into the zinc chloride flux. So, here that means there are rollers. Once we dip this into the zinc chloride flux, that zinc chloride has been coated on the surface of this mild steel or wire. Then it is again passed through the squeeze rollers for the uniform coating, and then passed through the oil or grease to remove, and then tinned metal. Tinned metal, which is coated metal, steel. At what temperature tinning we are doing? Somewhere 250 to 290 degrees centigrade. Such a high temperature. Okay. At this temperature only the tin or zinc will be in the molten state. Now, explain the process of tinning. What's happening? Tinning is the process of coating the base metal with tin. Yes, as I said while ago. First, what we are doing? We are taking the tin and we are boiling the tin at somewhere more than 300 degrees centigrade to make the molten tin. Molten is nothing but liquid tin. Liquid tin. Tin is nothing but SN. And into that molten tin, we are sending these mild steel or wires for the coating. So, that is nothing but process of tinning. The base metal surface is washed with organic solvents to remove oil, grease and content of the any other unwanted content on the surface of metal. Then metal is passed through the dilute sulfuric acid to remove the rust and any other greasy or oily surface or deposits. The metal is passed through ammonium chloride and zinc chloride flux, then dipped into the molten tin. Finally, it is dipped in the palm oil to prevent the oxidation of the tin. And the excess of tin is removed by passing through the rollers by wiping. Yes, as I explained while ago. Tinning is widely used for coating the steel. Copper and brass steel sheets, which are used for the making containers for storing food studs, oil, kerosene, packing and food materials. Tinned copper sheets are used for making cooking utensils and refrigeration equipments. Why? Because they will be always exposed in the humidified conditions and if we do this kind of tinning process, we can prevent the corrosion. Alright. Major differences between impressed current cathodic protection and sacrificial anodic protection. The main difference between two methods is that impressed current cathodic protection uses an external power source to nullify the electrons which are released at oxidation point. While the sacrificial anodes cathodic protection uses the naturally occurring electrochemical potential difference between different metallic elements to provide the protection. Okay, these are the differences between sacrificial anodic protection and impressed current cathodic protection. Now, these are the references for these modules, and finally, thank you.